Welcome back to our StrikeHold Corrosion Test Series. In today's experiment, we're focusing on something simple yet revealing: steel wool. Steel wool is made of thin metal strands, giving it a huge surface area that reacts quickly to water and air. This makes it the perfect candidate for testing how well StrikeHold can prevent rust in harsh environments. We're comparing two identical samples, one completely untreated, and another coated with StrikeHold. Both are submerged in 3.5% salt water, a concentration similar to seawater. The purpose of this test is to visually demonstrate the difference between protected and unprotected metal fibers. Our setup is simple and transparent. Each piece of steel wool sits in a small clear dish filled with 3.5% salt water. The only difference is the protective StrikeHold coating on one sample. The test was launched at 11:50 a.m. Eastern Standard Time on November 6, 2025, and the entire process is being monitored live. Scan the QR code to follow the experiment live. Here, you can clearly see how the samples are arranged. On the left side of the table is the untreated steel wool. It's completely bare, directly exposed to the salt water solution. On the right is the StrikeHold treated sample. The table labels mark the difference so we can observe each side easily over time. Every environmental factor, light, temperature, and humidity, is kept the same. That means the only variable in this test is the presence of StrikeHold. Any difference we see will come down to protection, not coincidence. Steel rusts through a process called oxidation. When iron reacts with water and oxygen, it forms iron hydroxide, which then transforms into iron oxide, what we recognize as rust. The chemical reaction can be summarized as 4 Fe plus 6 H₂O plus 3O2 yields 4 Fe open parenthesis O, H, close parenthesis 3, which then dehydrates into Fe₂O₃, rust. StrikeHold interrupts this reaction. It forms a hydrophobic barrier, meaning it repels water, and also acts as a dielectric layer, blocking the flow of electrons that drive corrosion. By sealing the metal surface at the molecular level, StrikeHold prevents oxygen and moisture from making contact, stopping rust before it starts. As the hours and days pass, you'll begin to notice the difference. The untreated steel wool will darken first, then small patches of orange-brown rust will appear. That's oxidation in action. Meanwhile, the sample protected by StrikeHold will stay clean, showing little to no change in color or texture. Even though both are in the same salt water solution, the treated piece resists the corrosive process that destroys bare metal. This simple side-by-side test makes the effect of StrikeHold protection visible and undeniable. This experiment shows how even delicate metal fibers like steel wool can stay protected under continuous salt water exposure when treated with StrikeHold. It's a small-scale test with a powerful message. Real protection at the molecular level that makes a visible difference. Stay tuned for our result analysis video, where we'll present the time-lapse footage and review the outcome over several days. Thank you for watching, and don't forget to subscribe for more corrosion experiments and StrikeHold performance demonstrations.